Hey everyone, this video is over the Unit 5 test review, and this will be Part 3, solving systems of quadratics and linear functions. We're looking for where a quadratic function, which is always a U-shaped graph, is going to intersect a linear function, which is always a straight graph. Our solutions will be the points where they cross. So they could cross in two places, like in this example. They could cross in one place, like in this example, or it is possible for them not to cross at all. For example, if it was in this format. So we can have 0, 1, or 2 solutions to this system. This goes along with the 5.3 notes on the website, so if you need more examples, you can check the section 5.3. So number 1, it asks us to solve by substitution. To show your substitution steps, you can take everything that y is equal to, and you can plug it in for y in the other equation. So once I plug it in, it is going to look, and I always plug in with parentheses so that I can double check to see that there is nothing that needs to be distributed first. So I plugged it in, and now I'm going to continue my equation. Plus x equals 5. So that's how you would plug it in. If you by chance don't have a x or a y by itself that you can plug in, you're going to have to rearrange one of the equations to get an x or a y by itself. You have to have something to substitute in if you're going to use the substitution method. So in this example, there is nothing to distribute, and there's nothing being multiplied times what we plugged in. So the parentheses don't really mean anything, so I can go ahead and simplify this down. There's nothing to combine the x squared with, so I'm just going to bring that down. I do have some x's that I can combine. I've got a negative 6x and a positive 1x. Those would be combined to be a negative 5x if I add them up. And I'm going to bring down my plus 9 equals 5. Now, in order to solve a quadratic, we have options. We can use the quadratic formula. We can factor it. We could do a graph, put in the y equals. Or we could complete the square. When we solve algebraically, though, our options are narrowed down to factoring. And you could do the quadratic formula, but that's going to be really long. So we always try to factor first, and if that doesn't work, our plan B is to try the quadratic formula. So let's see if this is factorable first. In order to factor it, I need to have it equal to 0. So I'm going to minus 5 on both sides so that it's equal to 0. That will cancel on this side. And I'm left with x squared minus 5x. 9 and 5 combine to be 4. So that means I am looking for, to factor this, numbers that multiply up to 4 and add up to the b, which is negative 5. So let's brainstorm. What multiplies up to 4? Well, we've got 1 times 4, and we've got 2 times 2. Now, whenever I'm multiplying to a positive number, both of the numbers either have to be positive, which 1 plus 4 gives me positive 5, not negative 5. 2 plus 2 gives me 4. So I'm going to have to use the second option, which is both of them could be negative. So if I made both of these negative, negative 1 and negative 4, that adds to negative 5. So those are my two factors. I've got x minus 1 and x minus 4. If you're still not good at factoring, refer back to last unit's videos on factoring. I showed two methods in there. One was the slide and divide method, and another method was on the Xbox factoring. So use one of those methods or Google your own, but you got to know some way so that you're good at factoring to be able to solve this quadratic. Now, once you get it factored, to find your solutions, you are going to set both of your parentheses equal to 0. That will help you find your two solutions. And then you will solve for x. So in this case, I need to add 1 to both sides. And my first solution is 1. For my second solution, I need to add 4 to both sides. And my second solution is 4. Now I have the x parts of where they're intersecting, but I need the y to go with it. I need the coordinate. So I'm going to plug my x into the original equation. Now you can plug it in this equation for the x's or this for the x, which looks like a much easier problem to plug in. So y plus x equals 5. Let's bring that down here. Y plus x equals 5. So for this first one, if I plug in 1, I can see that my y is going to be 4. If I minus 1, I got 4. So my first answer is 1 for the x, 4 for the y. That's my first solution. All right, let's plug it in for the other equation. I've got y plus 4 equals 5, which means that this y is going to be 1. So my second solution is 4, 1. So those are the 2 points that they would cross at. Now, a good way to check your answer would be to put your original equation into the y equals. You would have to minus the x to the other side, but then you could put this into the y equals. And you could look and see where are the points that they intersect. If you did it correctly, it should be 1, 4, and 4, 1, the points that we found. You should get the same solution. So even if you forget how to answer this problem algebraically, you could at least do it by plugging it into the y equals and get half credit. But you would have to show all this work in order to get it by the substitution method. To get full credit, you need to show all of your steps on how you solved it algebraically using the substitution method. One more problem from this section. This problem seems to be giving students trouble, so I wanted to talk about this one here. A ball was tossed and followed the path of a parabola. So we know it's going to have that U-shaped path. At 0 seconds, the height of the ball was 9 feet. Since this has a lot of information, I'm going to go ahead and record the data as we go. At 0 seconds, it was at 9 feet. At 1 second, the height of the ball was 10 feet. And at a time of 2 seconds, the height of the ball was 5 feet above the ground. Write a quadratic function to represent the path of the ball. So using these 3 points that they gave us, we can plug our calculator to get the equation. So if you click on your calculator on the Stat button, you are going to hit Enter on Edit, and you are going to type this data into your L1 and L2. All your seconds you'll put in L1, and all of your feet you'll put into L2. Once you get your data in, hit Stat again. And since we are doing a quadratic function, you want to click over to Calc and down to option 5, which says Quadratic. Quadratic is if you are doing a quadratic regression, which we are in this case. If they tell you that it's going to be a quadratic function, you want to use that regression. Then you hit Enter until you get an equation. You will need to plug in the A, B, and C for those values in the equation. And you should get y equals, I got negative 3 for the A. I'm going to plug that in for A. Negative 3x squared plus plug in the B value of 4x plus plug in the C value of 9. And that will be your quadratic equation. All right, part 2 of this question says that an eagle standing on a cliff 12 feet above the ground, sorry for moving the problem there. So I was going to draw a picture here. We have an eagle standing 12 feet in the air, and the eagle flies downward at a rate of 2 feet per second. So since that is a feet per second, that is a rise over run scenario. So where it's telling us it's got a negative 2 slope. It's going down 2 feet per second. So the linear function to represent that is, since my slope is the negative 2, that's going to be my slope. And he starts 12 feet in the air, so that'll be a plus 12 for a y-intercept. So that is the linear function to represent the path of the eagle. So we're going to take the equation from part 1 and the equation from part 2, and we're going to see if we can find if the eagle catches the ball before the ball hits the ground. So I'm going to put both of these equations into the y equals of my calculator. I, of course, could use the substitution method and plug it in, but I can easily plug this into my y equals. So I put both of them into the y equals, and I look at my graph, and I can see it is just barely touching it in one place. So it does look like the eagle is going to catch the ball. The answer would be yes. At what time would the eagle catch the ball? Because I can barely see in my graph. I can see the graph kind of looks like this. So I'm looking for this point. Pretend like it's only touching it. It looks like in my graph on my calculator that it's just barely touching it. And I can calculate the intersection if you go to second in your calculator, second, calc, which is in the top row of buttons. And then you're going to go to intersection, which is option 5. And then you will scroll that arrow, the X I should say, over approximately where it intersects. When you do that, hit enter 3 times and it'll calculate it for you. And mine says that they intersect at approximately 1:10. So approximately 1, 10. Another way to verify that, if you go to your table, you can look where the y values are equal to each other. And if I go to my table, I see when x is 0, one of the equations is at 9 and the other one's at 12. When I go to 1 second, they both are at 10 feet. So that tells me that they do intersect. So at what time does the eagle catch the ball? Well, my time is seconds. This should be feet. I'm not exactly sure why I put seconds there. So my time, my x, is 1. So after 1 second, the eagle will catch the ball. How high above the ground? Well, that's going to be my y value, which is at 10 feet. So that's what you're looking for in your calculators. You're looking for where the linear equation intersects the quadratic, and you can find it in your table and in your graph, so whichever one works for you.